Have you ever asked yourself, what if there was another manner to explore space? Nowadays, it takes from 6 to 8 months for spacecrafts to reach Mars. Let's think about how chemical rockets work. Chemical rockets expel a mixture of oxidizer and fuel, usually oxygen and hydrogen respectively, producing thrust through the exhaustion of water, H2O. Now, what comes to your mind when you think about nuclear power? Nukes? North Korea? Diminishing greenhouse gases? Well, you're right, but what if I tell you that there is a way to reach new limits? A way to travel through space that will not only faster colonization of Mars, but will also allow us to explore new frontiers in our own solar system. Nuclear thermal propulsion, a concept that was developed during the 50s that has proven to work. Instead of using a mixture of oxidizer and fuel, NTP utilizes heat and fuel. The heat generated from the reactor through the process of fission expands a low-density gas such as hydrogen. The fuel flows to the reactor, which produces thrust, similar to how chemical rockets work, but without the need for an oxidizer to produce thrust. Chemical rockets need to carry their own oxygen in a tank in order to produce its thrust, which decreases the amount of payload that it can carry. Now, with a nuclear thermal rocket, no oxidizer is needed, which means that you could either carry more crew members, payload, or increase its final velocity. Currently, NASA and many other space agencies around the globe need to wait 26 months for Mars to align with Earth in a launch window of 30 days to send their probes and rovers to the red planet. NASA's Perseverance rover is set to launch by the end of this month, and if they fail to launch, they will have to wait for another 3 years. But fortunately, that is not the case on a nuclear rocket. Its high specific impulse allows it to have a much wider launch window, which would allow flexible launches, and waiting 26 months for the alignment would be just something from the past. A trip to Mars would take from 3 to 4 months instead of 6 to 8 months, which would highly decrease the amount of cosmic radiation that the crew might be exposed. Now, you might ask, well, why are we using them? Why do we still rely on chemical rockets? And that's a great question. Unfortunately, NERVA, the government organization that was in charge of developing the engine, was shut down because Americans had won the Cold War by sending men to the moon, which shows the sad reality that most scientific developments are only backed up by the government when there is a political reason behind it. But recently, Congress awarded $125 million to NASA in order to further re-explore this concept. And just think about that, if we had successful tests with nuclear propulsion 65 years ago, imagine what we were able to accomplish with today's technology. Rockets are essentially missiles that, instead of destroying, builds the possibility of a new future where humans are in an interplanetary civilization. Now, what if we could reshape the way we go to space? Instead of riding missiles, why can't we build spaceships? Some of the main issues with nuclear propulsion was the fact that the rocket would need a material that could resist temperatures up to 3000 degrees Kelvin and higher, a lightweight material for the reactor, and the dangers of highly enriched uranium. Nowadays, we have materials such as tantalum carbide and hafnium carbide that can withstand temperatures up to 4000 degrees Kelvin. And keep in mind that our sun's surface temperature is about 5000 degrees Kelvin. Our technology has already advanced to a point where we already have small modular nuclear reactors, and the discovery that thorium could replace the reactor's uranium is a game changer. With current technology and materials, I believe that it can be done, and nuclear thermal propulsion is just part of the solution. Aerospace engines, 3D printed rocket parts, and single stage to orbit rockets, and of course nuclear power, are the main variables for a future spacecraft. And how many frontiers can we break using this technology? With this method of exploring the outer space, we're able to get to Mars not only faster, but also reach for the moons of Jupiter. We could even get to the boundaries of our solar system. My vision of humanity's future is a time where space travel can be compared to today's air travel, where you could either own a spacecraft or travel on a public spacecraft, much like today's private and commercial airplanes. Stay tuned for our next video and let me know down in the comments what you guys think about nuclear thermal propulsion, and don't forget to like this video, subscribe, and always stay curious. Thanks for watching and stay safe.